Hello and welcome to one more tutorial on using I2C LCD screens with the Arduino Uno. In this tutorial, we'll be using a timer overflow interrupt to increment a value in the Arduino Uno. This incremented value will be displayed on the LCD timer. So here's our setup. There's the Arduino Uno, the MB102 power supply and the I2C LED. Let's look at the connections in a little bit more detail. To the left is a jumper connection between the Arduino and the breadboard. Then we have the Arduino's A4 and A5 connections going to the LCD screen. The positive and negative rails from the breadboard are taken to the LCD screen and the ground of the power supply is connected to the Arduino. This is a very important point. Then we have the 5-volt jumper connected on the MB102 and the MB102 itself is plugged into the breadboard. Here's the connections on the LCD side with the SDA, SCL, VCC and ground pins duly connected. A little while ago, we ran an experiment and we scanned the I2C addresses to find out that the address of our LCD screen was 39 or 0x27. So this is going to be the address that we are going to use in our code. Please keep in mind that this code might be different in your case. Here's our shopping list, a 9-volt adapter, breadboard, MB102 breadboard power supply, jumper cables and the LCD I2C displays. The links will be in the description box. Here's the male and female connectors which we have used to set the Arduino free. So here's our code. We include the liquid crystal I2C library. As you can see here in this red circle, the address used is 0x27. We have a variable called cycle and a volatile variable called top. This volatile variable will be incremented in the interrupt vector. So in the interrupt vector, we prefer to use volatile variables since they are picked up from the RAM instead of being picked up from the registers, and that makes it more faster and error proof. We have initialized a string called top row cycles. So on the LCD screen, you would always see cycles printed out and next to it, the counter value would keep getting incremented. So here's the setup where we initialize the LCD object, clear it off to remove any existing text, turn on the backlight. Now we set this cursor to 0, 0 and print the top row, that is print cycles colon. After this, we type the value 0. Now here's our interrupt vector which fires every time the timer 1 overflows, and inside the loop what we do is, in case the interrupt vector has fired and top has been incremented, then the value of top will be greater than cycle. So if top is greater than cycle, then we set the value of cycle to top and then we go about printing this value of cycle onto the LCD screen. Please note that on the LCD screen, we have already printed cycle. So we need to set the the cursor to just after the cycle, and that's where this piece of code helps us. Also remember that it's quite possible that you have already printed a previous value on the screen. So this little loop, this little while loop basically prints a set of blanks equal to the value of cycle. For example, if cycle is 10, then the value of I will be 2 because cycle will be converted to a string, its length will be taken and that will be 2. And this little loop will basically print 2 blank spaces. So it's basically equivalent to clearing the screen. So if you have 100 typed there, then it would basically print dash 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 and basically get rid of this 100 that's typed on the screen. And once the screen has been cleared, we are ready to set the cursor back to top row length, that is just after the text cycles, and we can now print the value. So we're ready to flash the code. As you can see in the code, I've got multiple prescaler values possible and I've selected the prescaler of 1024 as of now. So flash the code. The code's been successfully flashed, so I disconnect the Arduino Uno and turn on the power supply. And as soon as I do that, the timer starts to work. And because the prescaler is 1024, the values take quite a bit of a time to update. So now what I'm going to do is to comment out this line of 1024 and instead go in for 256, which is going to give me roughly a second. So I turn off the power supply to my circuit, connect the Arduino once again, and I flash the code. The code's been flashed, so I disconnect and turn on the power supply, and the timer fires off, and this time you can see that it's approximately incrementing at 1 second each. So we play around a bit more. I turn this off, connect the Arduino again to the PC, and now we're going to have fun by connecting it to the no prescaler option. So here we go. Flashing successful. I disconnect the Arduino, turn on the power supply, and now you can see that the timer goes really fast. It's so fast that you can't even see it. Thank you for watching this video. Do subscribe to our channel and don't forget to play around with the prescaler values and run this experiment in a number of different ways.